problems in this class. And really, it's the mindset that you want every class beyond this, because it's pretty much the same way for everything beyond this. They don't tell you what to do. Okay? In Algebra 1, it was, here's an expression, simplify it. Here's an expression, evaluate. Or here's an expression, here's some numbers, substitute. And it gave you an idea of what to do. In geometry, in advanced math, and trigonometry, in your science courses, like physics and things like that, they don't do that. Right? They give you some relationships. You develop an equation from those relationships. And then that equation, the way it's developed, the makeup of it, tells you kind of implicitly on what to do. Okay? And I think we maybe find that out the first time in this assignment this year. Okay? But what we learn here and what we do today is not going to go away. It's Algebra 1 stuff that we're going to use consistently throughout this course, throughout your next Algebra 2 course. We use it all the time in advanced math, so it does not go away. As this process is going to be important for us to make sure we understand. One thing I want you guys to understand is that I cannot teach geometry and algebra at the same time in a 50-minute course, right? Okay. So, in the event that you struggle with some of this stuff, okay, today, the procedure we're talking about is called systems of equations. And that was a Algebra 1 standard. You probably spent 6-7 weeks on it in Algebra 1. Okay? I know we're not probably as good at that idea, that concept as we should be. I will talk about it, we'll discuss it, but it can't dominate the course, or we'll never get through the geometry. Does that make sense? Okay? So, on my website, towards the bottom, okay, it says if you struggle with the prerequisite algebra for this course, you want to spend time combing through the materials found below. So if I click on systems and equations, that is what we're dealing with today. There's a large collection of videos here that walk you through, and there's even these things down here at the bottom. These links are also additional videos, but it walks you through how to do systems and equations and all the different styles and all the different techniques that we can use to solve systems and equations. Okay. So in order to get good at this stuff, okay, you might be good at the geometry, and that's fine. That's great. That means I've done my job in teaching the geometry. But you still might be missing questions, because once you set up the equations using geometry, you have to rely on your Algebra 1 skills to solve it. Okay? I want to, but I can't teach the geometry and the Algebra 1 skills at the same time. So if you struggle and you have some issues with your Algebra 1, use these things as a tool. You have to put forth a little bit more effort than what maybe you've done in other courses. Okay? Same thing's going to happen when we get to factoring individually. Okay, and it'll come in a couple weeks. We'll factor quite a bit. And if you struggle with factoring, okay, you start to see the things that we can factor. Okay, you remember seeing stuff like this last year: x squared minus 2x minus 15. Okay, I'm going to factor that. If I struggle with that kind of stuff, ridiculous amount of videos here, hundreds of examples to go through and to practice. If you want to get good at this stuff, there are resources for you to do that. Okay. We talked about in the last class, if you're in a science class and you're trying to convert things, okay, they might not be all that explicit on how you convert. They might just say, change this feet into centimeters, or change these moles into, what do you guys change moles into? I've got good numbers. What? No? Atoms, okay. So you do that through using that concept of Avogadro's number, but through basically a 7th and 8th grade concept of unit analysis, and it just converts. It's taking like how you change inches to feet, right? It doesn't have to do that, right? You know how to change meters into inches and that kind of stuff. That's all you're doing in that science class, and that's why maybe sometimes you think, well, we're being asked to do a lot of things on our own and not maybe learn it in class, because it should have been learned as a prerequisite, right? It should have already been learned, and they're making that assumption. What I fear for you guys as a high school teacher, because I know where you're at, I know where you're going, I fear for you when you get to college and you don't have in your mindset yet of what a prerequisite course means, and you get to a college class and there's a prerequisite that you had to do well in a prior course, and you maybe got a B or C in that prior course. That professor teaches the current course as if you got a 100% and you didn't miss a single thing on that prerequisite course, right? But if you got a B or a C, you miss some stuff, right? You struggle with some stuff. But doesn't that mean you're going to struggle with some stuff in the current course? Unless you go back and do some extra work on your own. All right? I don't know how many former students, even friends and family members that I've known that have gone to college, and they've taken basically 1 semester, 2 semesters of college. Now they have about $25,000, $30,000 of debt, but they failed out of college because they didn't have that mindset to understand that. And I've got to do it. I passed this course. I get to the next one, and it's hard. And it's going to involve all the things I got to see in my last course. And I do that again. Eventually, you're going to kind of plateau out, and you're going to get a D or an E, and not pass that next college course, and you're going to fail out. Does that make sense? Okay. So at some stage, you guys got to realize that if I'm not picking up on some old information, I got to do something on my own. Got to figure it out on my own. Some of you are figuring that out. Some of you people are just waiting for it to click, and then that's not going to happen. Okay. You got to put some effort forward. These types of questions in geometry, hopefully we recognize and understand that we're looking at relationships. We're trying to see how things connect with one another. Okay. So how do these two angles, how do they connect? What's the relationship with them? Okay, the app to 180. What about those two? Also app to 180. Okay, what about those two? So they're equal. Okay? So, if you guys can tell me that, if you got all those three things right, you know the geometry. You've done a good job with the geometry. So I'm going to write those things down. I'm going to write that those two things were equal. 3x minus y equals 2y. I'm going to write down that those two things, x plus y plus 2y is equal to 180. I'm just going to do that. I'm going to actually do the addition. So I get x plus 2y and y is 3y is equal to 180. And then the last one, where those two were, I'm sorry, I did those two, didn't I? The last one was those two. So I'm going to add those together and get 4x negative y, positive y, what's that give me? 0y equals 180. So in this situation, we get three relationships. Okay. Now whether we need all three or not, I don't know. Okay. It's as we move through. If I write that first one down, that red one, I see two variables there, and that's a problem for us right now. That tells me I need another equation. So I need at least the blue one or the green one if I would have started with the red one. Does that make sense? Okay. Now every person did not start these problems and instantly get equation number 3 as the first equation that they came up with. If you would have, great, that's awesome. You probably instantly realize, like, x is going to be, what, 45? Okay. Pretty easy in that case. But if I would have developed these two first, I can't get that. Okay? I don't realize that. And my thought for you guys is when you see these problems, try to develop as many relationships as you can. Okay? And when you get these relationships, hopefully, maybe this one here, you develop one that's really easy to solve. These are a pain in the butt to solve, right? They have two variables. This one's easy. X becomes 45 when I do that division, right? Well, if that x was that x, or that x, okay, then that 45 is the same as that x and the same as that x. So I should be able to replace that 45 somewhere, right? Does that make sense, everybody? It doesn't matter which equation you do this to, either the red one or the blue one. If I plug in 45 plus 3y equals 180, I get 3y is equal to 135. Okay? Now y is going to be, what, 45? X is 45, y is 45. I would have gotten the same result if I would have plugged in x to be 45 to there. Does that make sense? All right. That problem is best solved by looking at all three equations and realizing these two are hard. maybe there's another equation that's a little bit easier. If you are robotic about things, and you don't pay attention to that, and you realize, oh, I got an equation with two variables, I need another equation that has two variables, and I go through and solve it, because we could use that red one and the blue one, and we'll do this in the next problem. We could use that red one and blue one together to get the same 45 for x and y. Okay? But it's probably 3-4 times longer of a process than what we just did. So my hope is that you look at all options. Okay? Look at all different routes that can be taken to solve this. If I look at, so that's question 10 from that assignment. If I look at this one, it's a very similar problem, right? You see the exact same picture. Still talking about three angles. Talk about those two. What's the relationship between those two? Half to 180. So equation 1 is going to be, I'm going to say 3x plus 4y equals 180. What is the relationship between those two? Half to 180. So I'll call this equation 2. Say 4x plus y. Maybe I shouldn't do this, but I will. We have it as, it should be 3x plus y plus 5 equals 180, right? There's a lot of like terms there, correct? What we eventually want to end up doing is combine those. Gives me 4x and y. Just going back to black, not green. 4x. Okay. Plus a y. I'm going to take that 5, I'm going to combine it with that 180. Got to move it over to the other side. So I do that through subtraction, gives me 175. We'll talk about why we did that here in a little bit. It makes things a little bit easier for the next step. But that's equation number 2. And then equation number 3. What do you recognize about that red angle and that red angle? Vertical, so they should be congruent. So we got 4y equals x plus y plus 5. Okay? And just like I did here in this green one, I'm going to actually rewrite that a little bit. I'm going to rewrite it as negative x. I'll move this x to that side. Move this y over there as well, so plus 3y. And I'll leave the 5 where it's at. Okay, so that's equation number 3. Now the reason I rewrote those, the red one and the green one, is because of how the blue one was written. Okay? And really because of the next couple steps that we have to do. But I just transformed the equation. So that black equation does the exact same thing the blue or the green one does. Okay? That red equation up top does the exact same thing that red one there does. Okay? We just transformed them, made them look a little bit different, moved things from one side to the next, that kind of stuff. But here's the logic on why we did that. Whenever I have an equation that has two variables, you cannot solve it, okay, by itself. You need another equation that has the exact same two variables. Okay? So if I write down 3x plus 4y equals 180, I can't solve that. So I need to look for another relation. So this is what we want to kind of program ourselves to do. Every time throughout the rest of this course, I write an equation, I write a relationship down, two variables, instantly think, I need another equation with the exact same two variables. So look for another relation. We get the green one. Okay? We could ultimately stop now. We could go equation 1 and equation 2, we can pair those together, and we can solve this thing. I went ahead and found the red one as well, because I was hoping that red one would have been kind of like this. Oh, went the wrong way. That red one would have kind of been like that green one, I guess, that disappeared. And in this question where 3x minus y and x plus y would have canceled out and just gave me 4x. Does that make sense? 4x equals 180 is what we had. So my hope is that additional relationship simplifies the entire process. Here it doesn't, so what do I do then? How do I default back to still being all solved for x and y? And this is how you do it. You're going to take any two of those equations, doesn't matter. Blue one and the green one, the blue one and the red one, the green one and the red one, does not matter. I'm just going to take the first two. Take 3x plus 4y equals 180. And I'll take 4x plus 1y equals 175. Okay? And this procedure, the way I set this up is the reason we rewrote the green one this way and we rewrote the red one that way if we were going to use the red one. Because what we want to happen when we take these two equations, we want a column of x's we want a column of y's, and those are referred to as your constants, but we want those to be in column. We want those things stacked on one another. Okay? If you guys remember from last year, this is referred to as a system of equations. And we're going to solve this using a technique called elimination. Okay? So that's the vocabulary that's going to be important. When I say, hey, here's a system, solve it using elimination, solve it using substitution. That's vocabulary from last year that's important to us. If I'm going to use elimination, what we want, the word elimination means to get rid of, right? To eliminate, to cancel out. What we want to do is we want to add straight down. Okay, these columns. So there I get 7x, here I get 5y, and here I get what? 355. Okay? We want to add straight down. And the hope is that when I do that, either that 7 or that 5 turned into a 0. Okay? Because if I have 0 times x, that's just 0, right? And that variable disappears. And now all I'm left with is y equals nothing. Or if I get 0 times y, that's just 0. So now I have 7x equal to just amount. Okay? So in this situation, that did not happen. So we can't just add straight down. We have to manipulate the equations a little bit. Okay? And you're allowed to manipulate one equation, manipulate both equations, and you can do that manipulation through multiplication or division. Okay? Last year, you're probably just taught to do it through multiplication. That's fine. You can always do just multiplication if you want to. So what you want to do is you want to look at these coefficients for respective variables and just choose the ones that you want to cancel out. Okay? Well, if I want the x's to cancel out, I have to make sure I can take both those coefficients and turn them into opposite numbers. Does that make sense? So I either need to take the 3 and turn it into a -4, or take the 4 and turn it into a -3. Well, that's kind of hard. I have to use fractions to do that. Okay? Some of you might say, well, last year we went ahead and we changed the 3 into 12, and then changed the 4 into 12, right? Remember that? Perfectly fine. You can do it that way. It's a little bit more work than what this problem requires. Because if I look at the blue stuff, isn't it going to be easier to take that 1 right there and change it into a -4? All right. So I'm going to take this bottom equation. I'm just going to transform it. I'm going to multiply it by that constant of -4. And what people make mistakes with is they don't multiply everything. They forget to multiply something by that -4. So the bottom equation becomes -4 times 4 gives me -16x. -4 times 1 gives me -4y. Okay. 175 times 4, 180 times 4 would be 720. Okay, but I increased by 5 and multiplied by that 4, so that's 22 much. So 7 should be 700. Okay. So -700. There was a negative times a positive. So I just transformed that equation. That equation I just got in red does the exact same thing to x and y that this equation did. Okay. Just every component is 4 times bigger, and that's fine. Okay. The number one mistake that people forget to do is they multiply the -4 by the 4x and by the 1y, but they leave this as 175. So make sure you don't do it. Make sure you multiply everything by that -4x. The top equation, then change it all. So I'm just going to rewrite 3x plus 4y equals 180. Okay. Now we can add straight down. What happens to my x's? What do I get when I add straight down? -13x. What happens there? They cancel out. You get 0y. Okay? And that tells you instantly that you've done something correct. Okay? And so far you're on the way of getting the right solution. Okay, now what's that become? -520? Okay. How many times does 13 go to 52? Okay. 4 times. Okay, so 13, they're both negative, so I don't care, so I'm going to assume they're both positive. 52 divided by 13 gives me 4, so 520 divided by 13 would give me 40. Make sense? So x is 40. Now, if x is 40, that x is the exact same x that we saw everywhere else in any other equation that we ever came across. So if that x is 40, it's 40 right there, it's 40 right there, it's 40 right there, right there, and right there. Does that make sense? So when you solve for y2, right? And once you find one of your variables, take any one of your equations that you set up prior and plug in it and just do substitution. I always go back to what I think is the simplest. I think that looks pretty simple. So we go 3 times x being 40 plus 4y equals 180. 120 plus 4y equals 180. We get 4y is equal to 60. Y then ends up being 15. Okay? You should always have a built-in check. X, and it usually comes back to the picture. If x was 40, and y was 15, can I plug in 15 here and get 60? Okay? Plug in 40 plus 15 plus 5 gives me 60. Plug in 40 here gives me 120. And what do you know about 60 and 120? What do they add to? 180. What about that 120 and 60? 180. What about those two numbers? They're the same. And those are the built-in checks. If I get any other number, if I go through that math, I get x to be 39 and y to be 15. Those relationships will not exist. Okay? Prepare for tomorrow's test.